Picture this: a gentle breeze rustles through the trees, carrying with it the promise of a cleaner, greener future. That same wind that tussles your hair holds the key to powering our world sustainably. Intrigued? You should be. Welcome to the Clean Energy Journey YouTube channel, where science meets sustainability. We share how green energy will save our planet in the future. Today, we're re-diving into the fascinating world of wind energy, a powerhouse in the fight against climate change. Wind power isn't just a passing trend. It's a crucial player in our global energy transition. As we shift away from fossil fuels, wind turbines are popping up like eco-friendly giants across landscapes and seascapes alike. But why does wind energy matter so much? Well, it's simple. Every megawatt of wind power generated is a breath of fresh air for our planet. It's slashing greenhouse gas emissions, boosting energy security, and aligning perfectly with climate policies in countries like the US, UK, Australia, and Canada. The urgency is real, folks. Our climate can't wait, and neither can we. Now, let's get down to the nitty-gritty of how these towering turbines actually work. It all starts with the wind itself, that invisible force created by differences in air pressure and temperature. As the wind blows, it carries kinetic energy. Remember that equation from physics class? Kinetic energy equals 1/2 mass times velocity squared. This means that even a small increase in wind speed can dramatically boost the energy we can capture. It's why wind farm locations are chosen with such care. We re-after those sweet spots where the wind blows strong and steady. So, what exactly are we looking at when we see a wind turbine? Let's break it down. You've got those massive blades, aerodynamically designed to catch the wind like a sail. These connect to the rotor hub, which in turn links to the drive shaft. All of this sits atop the nacelle. Think of it as the turbine's engine room. Inside, you'll find the gearbox in most models and the generator. And of course, there's the tower, lifting everything high into the air where the winds are stronger and more consistent. Now, let's follow the energy as it flows through the turbine. It's a beautiful dance of physics in action. The wind hits those huge blades, creating lift, just like an airplane wing. This causes the rotor to spin. In most turbines, this rotation is too slow for electricity generation, so a gearbox steps in to increase the speed. The now rapidly spinning shaft connects to the generator, where the real magic happens. Inside the generator, we witness the wonder of electromagnetic induction. Spinning magnets near coils of wire create an electric current. It's the same principle that powers everything from massive power plants to the dynamo on your bicycle. This electricity then flows down the tower through a transformer to adjust the voltage, and out into the grid to power our homes and businesses. But here's where it gets interesting. Not all turbines are created equal. Some use a gearbox system, which is tried and true but requires regular maintenance. Others opt for a direct drive setup, eliminating the gearbox entirely. This means fewer moving parts, potentially higher efficiency, and less maintenance. However, direct drive systems often come with a heftier price tag up front. It's all about balancing initial costs against long-term benefits. Let's zoom in on that generator for a moment. It's the heart of the turbine where mechanical energy becomes electrical current. Some use synchronous generators, others asynchronous, each with its own pros and cons. The efficiency here depends on factors like the type of generator, the materials used, and even how well it's cooled. Every detail matters when you're trying to squeeze out every possible watt of clean energy. Once that electricity is generated, its journey is far from over. From the turbine, it travels to a transformer, then to a substation. From there, it hits the high-voltage transmission lines, those big ones you see stretching across the countryside. Eventually, it makes its way through distribution networks and into our homes and businesses. Grid operators play a crucial role here, constantly balancing supply and demand to keep our lights on and our devices charged. Now, you might wonder why some wind farms seem to produce more power than others. It all comes down to a few key factors. Wind speed is the big one. Remember that cubic relationship we mentioned earlier? A small change in wind speed can mean a huge difference in energy output. Then there's turbulence, which not only reduces efficiency but also increases wear and tear on the turbine. The size of the turbine matters too. Bigger rotors can capture more energy. And of course, location is everything. Offshore wind farms, for instance, often have higher output thanks to stronger, more consistent winds. As with any technology, wind power comes with its own set of benefits and challenges. On the plus side, it's a clean energy source that creates jobs and promotes energy independence. But we can't ignore the concerns about visual impact, noise, and potential risks to wildlife like birds and bats. There's also the issue of intermittency. The wind doesn't always blow when we need power most. Economically, wind energy has become increasingly competitive, but factors like subsidies and market dynamics still play a role in its adoption. Looking to the future, wind energy is set to soar to new heights, quite literally. Offshore wind farms are expanding rapidly, taking advantage of stronger winds and reduced visual impact. We're even seeing the development of floating turbines, opening up deep water sites previously out of reach. Advances in materials science are giving us lighter, more durable blades. And as we integrate wind power with smart grids and energy storage solutions, we're addressing that intermittency challenge head-on. As we wrap up our journey through the world of wind energy, take a moment to appreciate the next breeze you feel. It's not just moving air, it's potential. Potential for clean energy, for a sustainable future, for a planet where we harness nature's power without depleting its resources. From the gentle rotation of turbine blades to the electrons powering your screen right now, wind energy is transforming our world, one gust at a time. Keep exploring, keep questioning, and keep supporting clean energy innovations. Together we can turn the tide on climate change and create a brighter, cleaner future for all. Until next time, this is the Clean Energy Journey, where science meets sustainability and the winds of change are always blowing strong.